Shit! Call 911!
Oh, bad. Many emergencies often happen in our lives. How do we know the place we live is safe? What's related to our life safety? We can do research through the data set of life safety.
我是406421317统知视角的朱品谦。I'm going to talk about the data mining final report for our data. First, I'm going to talk about our data sources. All of the data we find is from the open data in 2009. This is the data sources. Next, I'm going to talk about the data reprocessing. We can see that some of our data have same digital. It's because our data unit is Taiwan City, but some of the data don't have its administrative district data. Only have its city data, like in the variable number of the police, only have the data of Taipei City. But data has said that city data can be regarded as administrative district data, because the resources in city is also in its administrative district. So we can use city data to be our administrative district data. And in our data, I have already deleted some of the variables. Most of them have too much missing value that can't be used in our report. And I also deleted the data from the outlying island like Jinmen Mazu. We take an example for this. We can see that it's because their data having a lot of missing value or its value is too small that can't be used. That can be an outlier value. Both of these reasons can affect the result of our report, and maybe it will make our conclusion wrong. Next, I'm going to talk about our variable description. So this is our final Excel for our report. Our data is for Taiwan security set, and our target variable is 生活安全指数. We find a lot of data like numbers of officers, numbers of hospitals. All of this data is from the different data. But what do we find? The data are all highly correlated with 生活安全, so we try to combine them into one data.
Here I'm going to introduce the association rules of our dataset. I use a priori algorithm to find out the rules. Here's the result I get by using WECA. As you can see, 警察人数 is associated with 生活安全指数, and so is 消防人数. It seems like more number of crew won't increase our life safety, but I think it's not reasonable. So I look into our data and found that most of the area have low 生活安全指数. To solve the problem, I resampled the data to make 生活安全指数 uniform distribution, then do it again. This time, I found that 消防人数 is still associated with 生活安全指数, but some other rules was found. As you can see, higher 救灾体勤务车辆 and lower 救护车 usually related to higher 生活安全指数. And here's the result I got by using our language. You can see both 警察人数 and 消防人数 still associated with 生活安全指数, and the number of crew won't increase our life safety. Comparing the result of WECA and our language, you can see that they have same result.
And finally, if we run the all attributes, the result is 84% correctly, and the number of leaves is 9. The number of trees is 17. I first divide the life safety index 1 to 5 into low, and 6 to 10 into high. The best choice for CFS results is the township city code and township city name, number of police officers, and number of the ambulance. The result is that the correctity rate is 82%, and the leaf number is 5, and the number size is 9. Then the infogame results detect the number of police stations, the number of hospitals, and the number of clinics. The result is the correct road tag is 83%, and the number of leaf is 3, and number of tree is 5. The above is based on the results of an optimistic rule. Now we apply the function of the pessimistic rule to see the results, which are CFS is 84% and infogame is 82%, all attributes is 83%.
我是统治三甲林文浩。This is the dataset for hierarchical clustering. There are 5 ways to do hierarchical clustering. There are decision trees for simple method, complete method, and average method. There are decision trees for central method and words method. As we see, there are no obvious difference between these 5 methods, so we decided to compute agglomerative coefficient. We can see words method has the highest agglomerative coefficient, so we decided to use words method. Based on elbow method, we decided to divide it into 3 clusters.
我是统治三甲陈俊宇。I'm going to introduce the k-means of data. First, we need to choose the k-value. We use the elbow method. We can see that k equal to 3. That is the best choice. We say C equal to 2021. The centers equal to 3. The end star equal to 15. And take a picture about how to cluster. We can find that if E have an outlier upper left corner, so it becomes a unique cluster. Clustering with Weka, we choose the same k-value and C. The sum of square is about 75. The form is each cluster. We can see the class 0 have the best number of every variable. The class 2 is the worst. Visualize it. We change the x and y axis. We can find there are many squares. We choose 2, which have almost the same number of police officers, but the standards are different. So I think the judgment standards are not a good period. The next part is KNN. I use IPK of Weka. The option we choose the cross validation. The size is 358. We copy homework use k equals 1 to 30, and we find the best k-value is 4. It's about 93%. We also choose the 75% to be the training data set in R. The other 25 is testing data set. And we using the model and we find the max accuracy is 97%.
14062148统治四甲朱一鸣。Now we compare 4 methods to let 4 methods have the same testing option to predict. We said n was 2, cluster has k for 3, and sets it 2021. As you can see, in J48, the accuracy is about 85%. In CART, prune and unprune respectively has 91% and 89%, so we choose the model after pre-min. Third was k-min. When k is 3, it has a minimum SSE, and the accuracy is 75%. Finally, we find the KNN has a highest accuracy than other our testing data. It's about 97%. Conclusion: we can find the number of the clinics, police officers, and the firefighters have a greater impact on the life safety index. So, we will recommend that you can live in an area with a high number of these variables.
Based on the above data analysis, we can find that the number of the police officer and the number of the firefighter will obviously affect the life safety index, and the higher number of 救灾及轻忽车辆 will also be a higher life safety index. Therefore, it seems we can say that life safety index does not have much correlation with the number of the clinics or hospitals. After all, if someone smoking near your home and catches a fire, we would prefer the police to arrest him or a firefighter to put out the fire instead of the ambulance to rescue him.